Ivy Bridge is the code name for a line of processors based on the 22nm manufacturing process developed by Intel. The name is also applied more broadly to the 22nm die shrink of the Sandy Bridge microarchitecture based on FinFET tri-gate transistors, which is also used in the Xeon and Core i7 Ivy Bridge X, Ivy Bridge EP and Ivy Bridge E microprocessors released in 2013. Ivy Bridge processors are backwards compatible with the Sandia Bridge platform, but such systems might require a firmware update. In 2011, Intel released the 7 series Panther Point chipsets with integrated USB 3.0 to complement Ivy Bridge. Volume production of Ivy Bridge chips began in the third quarter of 2011. Quad-core and dual-core mobile models launched on 29 April 2012 and 31 May 2012 respectively. Courier i3 desktop processors, as well as the first 22nm Pentium, were announced and available the first week of September 2012. Overview: The Ivy Bridge CPU microarchitecture is a shrink from Sandia Bridge and remains largely unchanged. Like its predecessor, Sandy Bridge, Ivy Bridge was also primarily developed by the Intel's Israel branch. Notable improvements include 22nm tri-gate transistor technology, a new random number generator and the RD-RAND instruction, codenamed Bull Mountain. Ivy Bridge features and performance: the mobile and desktop Ivy Bridge chips also include significant changes over Sandia Bridge, F16C. RD-RAND instruction. PCI Express 3.0 support. Max CPU multiplier of 63. RAM support up to 2800 MTS in 200 MHz increments. The built-in GPU has 6 or 16 execution units, compared to Sandia Bridge's 6 or 12. Intel HD graphics with DirectX 11, OpenGL 3.1, and OpenCL 1.1 support. OpenGL 4.0 is supported with 10.18.10.3621 WHQL drivers and later drivers. DDR3L and configurable TDP for mobile processors. Multiple 4K video playback. Intel QuickSync Video version 2. Up to 3 displays are supported. A 14 to 19 stage instruction pipeline, depending on the micro-operation cache hit or miss. Benchmark comparisons: compared to its predecessor, Sandy Bridge, 3% to 6% increase in CPU performance when compared clock for clock, 25% to 68% increase in integrated GPU performance. Thermal performance and heat issues when overclocking: Ivy Bridge's temperatures are reportedly 10 degrees Celsius higher compared to Sandy Bridge when a CPU is overclocked, even at default voltage setting. Impress PC Watch, a Japanese website, performed experiments that confirmed earlier speculations that this is because Intel used a poor-quality thermal interface material between the chip and the heat spreader, instead of the fluxless solder of previous generations. The mobile Ivy Bridge processors are not affected by this issue because they do not use a heat spreader between the chip and cooling system. Enthusiast reports describe the TIM used by Intel as low quality, and not up to par for a premium CPU, with some speculation that this is by design to encourage sales of prior processors. Further analyses caution that the processor can be damaged or void its warranty if home users attempt to remedy the matter. The TIM has much lower thermal conductivity, causing heat to trap on the die. Experiments replacing this with a higher quality TIM or other heat removal methods showed a substantial temperature drop, and improvements to the voltages and clocking sustainable by Ivy Bridge chips. Intel claims that the smaller die of Ivy Bridge and the related increase in thermal density is expected to result in higher temperatures when the CPU is overclocked. Intel also stated that this is as expected and will likely not improve in future revisions. Models and steppings: all Ivy Bridge processors with 1, 2, or 4 cores report the same CPU ID model 0x000306A9, and are built in 4 different configurations differing in the number of cores, L3 cache and GPU execution units. Ivy Bridge E features: Ivy Bridge E is the follow-up to Sandy Bridge E, using the same CPU core as the Ivy Bridge processor, but in LGA 2011, LGA 1356 and FCLGA 2011 packages for workstations and servers. Dual memory controllers for Avaya Bridge EP and Ivy Bridge X, up to 12 CPU cores and 30 MB of L3 cache for Avaya Bridge EP, up to 15 CPU cores and 37.5 MB L3 cache for Avaya Bridge X, thermal design power between 50 AW and 155 AW, support for up to 8 DIMMs of DDR3-1866 memory per socket, no integrated GPU. Ivy Bridge EP introduced new hardware support for interrupt virtualization, branded as API-CV. Models and steppings. The Ivy Bridge E family is made in 3 different versions, by number of cores, and for 3 market segments. The basic Ivy Bridge E is a single-socket processor sold as Courier i7-49XX and is only available in the 6-core S1 stepping, with some versions limited to 4 active cores. Ivy Bridge EN is the model for single and dual-socket servers using LGA 1356 with up to 10 cores, while Ivy Bridge EP scales up to 4 LGA 2011 sockets and up to 12 cores per chip. There are in fact 3 die flavors for the Ivy Bridge EP, meaning that they are manufactured and organized differently, according to the number of cores an Ivy Bridge EP CPU includes. The largest is an up to 12-core die organized as 3 4-core columns with up 30 MB L3 cache in 2 banks between the cores. These cores are linked by 3 rings of interconnects. The intermediate is an up to 10-core die organized as 2 5-core columns with up to 25 MB L3 cache in a single bank between the cores. The cores are linked by 2 rings of interconnects. The smallest is an up to 6-core die organized as 2 3-core columns with up to 15 MB L3 cache in a single bank between the cores. The cores are linked by 2 rings of interconnects. Ivy Bridge X has up to 15 cores and scales to 8 sockets. A 15-core die is organized into 3 columns of 5 cores, with 3 interconnect rings connecting 2 columns per ring. Each 5-core column has a separate L3 cache. The processor is supposed to have a new run-sure technology, speculated by the odd number of cores to involve keeping one in reserve. List of Ivy Bridge processors. Processors featuring Intel's HDA 4000 graphics are set in bold. Other processors feature HDA 2500 graphics unless indicated by NA. Desktop processors. List of announced desktop processors, as follows, requires a compatible motherboard. Suffixes to denote: Car Euro Unlocked, ZAR Euro Performance Optimized Lifestyle, TAR Euro Power Optimized Lifestyle, PAR Euro No on Die Video Chipset, ZAR Euro Extreme Performance. Server processors. Additional high-end server processors based on the Ivy Bridge architecture, codenamed Ivytown, were announced September 10, 2013 at the Intel Developer Forum, after the usual 1-year interval between consumer and server product releases. The Avaya Bridge EP processor line announced in September 2013 has up to 12 cores and 30 MB third-level cache, with rumors of Ivy Bridge X up to 15 cores and an increased third-level cache of up to 37.5 MB, although an early leaked lineup of Ivy Bridge E included processors with a maximum of 6 cores. Both Core i7 and Xeon versions are produced. The Xeon versions marketed as Xeon E5-1400V2 act as drop-in replacements for the existing Sandy Bridge EN-based Xeon E5. Xeon E5-2600V2 versions act as drop-in replacements for the existing Sandy Bridge EP-based Xeon E5, while Core i7 versions designated i7-4820K, i7-4930K and i7-4960X were released on September 10, 2013, remaining compatible with the X79 and LGA 2011 hardware. For the intermediate LGA 1356 socket, Intel launched the Xeon E5-2400V2 series in January 2014. These have up to 10 cores. A new Avaya Bridge X line marketed as Xeon E7V2 had no corresponding predecessor using the Sandia Bridge microarchitecture but instead followed the older Westmere X processors. Requires a compatible motherboard. Mobile processors, suffixes to denote: MA Euro Mobile Processor, QA Euro Quad Core, WA Euro Ultra Low Power, ZAO Euro Extreme, Euro Extreme Ultra Low Power Roadmap. Intel demonstrated the Horsewell architecture in September 2011, which began release in 2013 as the successor to Sandy Bridge and Ivy Bridge. See also: List of Intel CPU microarchitectures. References. External links: Intel Core i7-3770K Review, a small step up for Ivy Bridge. Tom's Hardware. April 23, 2012. Video animation, Mark Bohr Gets Small, 22nm Explained. Video presentation. Intel. Retrieved November 11, 2011. David Cantor. Intel's Ivy Bridge Graphics Architecture reworldtech.com. Retrieved April 24, 2012. Roundup, Intel Core i5 processors with Ivy Bridge microarchitecture. Xbit Labs. September 19, 2012. Roundup, Intel Core i3 processors with Ivy Bridge microarchitecture. Xbit Labs. September 25, 2012. Intel 3.5 GHz-LGA1155 Core i7-3770K processor price in India. Price India Review. Retrieved January 5, 2013.